G'day, Michael here. You may have seen various bits and pieces that I've put online on YouTube and so forth with the progress of my Core XY, the electronics and the bits and bobs to make it go, various pulley designs and things. Yeah, but what has been plaguing me is actually not this so much as a Black Widow. Every time I try to get a print done lately, it seems to be just failing me. There's a few things that need to be redone on this machine, and that is the V-slot arrangement. There you can see the end off. In a previous video I tried to show it very poorly, but here you can see how the V-slot works. In principle it's a lovely idea, and I was actually quite excited when I unpacked the Black Widow, how good a materials and design it was. But I actually have found some shortcomings with the V-slot. The big one is, the moment you try to get the thing firm, so there's no play, or you're trying to reduce the play down to something that's to generate some high precision, you generate also a lot of friction. My compressor's doing its thing. Okay, so these are the pulleys that run in the V-slot, and to get any decent precision, they actually start generating a lot of friction because you've got the two running surfaces at 45-degree angle. So they kind of wedge themselves in and bind while they're trying to rotate. The other thing I had, let me just get that adjusted. Okay, the other thing I had is this carriage, the X carriage. It had only 3 wheels, 2 on the top and 1 on the bottom, and it was very prone to being, it had a lot of wobble in it. Basically, you could move around a lot. Also, the V-slot rollers were running on the outside of this pair of separated parts. Now I'll just zoom out. Oops, down. I'm using a gimbal, and it smoothens some things out and makes things otherwise uncontrollable. Okay, so we've got 2 rails here, and we've got a set of rollers that run on the top and a single roller on the bottom. But the rails actually, under pressure, do deflect. I don't know whether it'll show up in the video. Probably not. Focus. Yeah. I can certainly see it here, and I can feel the deflection, and that produces the ability for it to wobble. Now, because the because the feeder and hot end are extended on the front of that carriage, it would be prone to catching and rotating the whole part around, and I'd lose my Y positioning. I've lost so many parts due to that catching. So I'm trying to work out a way of getting this more rigid. And for a start, I'm putting 2 bearings on the bottom there, and I've made up an assembly which I've partially tested. I don't know what that shows. Partially tested. I've got the ability to tighten this up neatly. I've had to buy different types of wheels just simply because they were available, and I've ended up using them on this device on the X carriage here. But it's quite surprising how poor the behaviour is actually of these pulleys. Yeah, but putting 4 on certainly makes it a lot more stable than the 3. Normally you'd think 3 would be enough, but it just the triangle's kind of too narrow, and it would rock sort of diagonally. It's hard to explain. Now that I've got it pulled apart, I can't even show you. Alright, but there's another flip side that's turned out to be quite an advantage to this setup. The V-slot rails are quite an open architecture type thing. Basically it's the same extrusion all the way through. Now, inside this enclosure, that's the hot bed, or print bed, whatever you want to call the thing. It's 250 by 400. Now the way this is designed, that carriage can move far more than 400 on that rail. But I need to mount the motor off that rail. The way Tevo had it mounted is the motor was set on top using up length here, and so it had about 300 millimeters of travel, but I'm going to mount the motor over the end at the back there, so it's not actually using up travel distance. I might be able to bump this thing's travel in that Y-axis out to maybe 400, maybe 450. I haven't done the exact numbers yet. But if I can get 450 out of it, I'll get a custom hotbed element made up, and I'll make my own plate for the hotbed. and I should be able to get quite a big print out of this thing. So I'll probably get a nominal, let's call it a 400mm cube near enough out of the Black Widow here. So I'm kind of happy that it's openly built, but I will have to beef up these various parts because this part here is cut off and is only held on by these brackets in the corner here. You can actually deflect. I can't hold the camera and deflect it at the same time, but this part here can actually rotate quite a bit within the way it's held. If this was a welded frame, it would be far better, but I mean, of course, it can't weld these sorts of sections. So yeah, I'm disappointed in some ways, but there's also a lot of scope for improvement with the V-slot arrangement. I really do like, see if we can get a good view of it. They've got the Z motor with a belt running to both screws, and the screws are actually quite a nice, they're like an Acme thread, fairly square looking thread. I don't know whether they are in fact Acme, but they look like it. And having a pulley running at either end to a belt and then up to, up to the Z motor. And you can see there's the ability to tighten up the slack in the belt. But it means that both axes work exactly identically, being belted together. Whereas on a little Prusa, they've got two separate Z motors. So there is a potential for them to go out of sync with each other. With this belt arrangement, everything's kept in sync. Alright. I do like the drag chain arrangement they've got on the, get this thing to focus, the drag chain arrangement they have on the Tevo. That's very nicely done. But in any case, the printer is simply not printing. It's been playing up. It's giving me lots of grief. Instead of printing out parts, I've had to stop and fix this device. I might just go get a few parts to show you the sorts of failures I've been getting. Okay, this part here, which is the main part, in a previous video I actually had this part printing in the Tevo. Basically, the hot end jammed, and to my mind it's simply the design of the hot end, which is a common design. It's also what I consider to be a common fault in the hot ends. The Teflon liner that goes through the heat break is exposed to too much heat down at the bottom end, so it does deteriorate quicker than I think it should. I don't think I can get more than about 6 or 7 kilos through one of these hot ends before it fouls up and jams. This thing, I had the tip wandering around about 10 millimeters above this part before I realised that it has stopped feeding the filament. And this part here indicates or shows how it would lose its Y position. The print is otherwise, it is meant to be a coarse and fast print. I had a 1mm tip belting these parts out, but if the tip gets caught, the Y-axis of course loses its position, and I've only ever lost position in the Y-axis, so it's exactly that fault. But what's really interesting that's come out of all this is all these problems that I've had with both the Prusa and the Black Widow, I have not had with either of the Deltas. And this Delta is actually producing the Y-axis mount right now for that Black Widow, so I can increase the travel in the Y. So it's just working like a soldier. It's been working really faultlessly. I suppose I might jinx myself, but it is certainly working rather well. And the big Cricket has been working very reliably. It's just been producing part after part after part, just the same. Basically, I've done the least modification of any of the printers that I bought on the Cricket. The only thing I've really done is I've rotated this base so as to get the wiring out of the road, because I actually did nearly fry the Z-axis auto level sensor. So that just basically means that I won't accidentally hit the wiring with the bulldog clips. Yeah, other than that, it's been a very reliable machine. I have had this 6mm aluminium plate, water jet cut, so I've got a removable bed. I've got it coated with PVA, and I get dozens of prints between resurfacing the aluminium. I'm very happy with the result of using PVA on the aluminium plate. Alright, so the actual parts that I'm working on now, computer, wakey wakey. That's the part that's in the Cricket right now. That is actually a part for the Core XY to hold the Z-axis motor and the coupling for the lead screw. I've got all this junk here. There we go. So we've got the motor in alignment with the lead screw. We'll have the coupling, and that device is to provide a well, basically a mount for every part that's involved. The bearing mount for the lead screw and also the motor mount. Alright, what else have we got going here? So that's the part in the other Delta that's going to be holding the Y-axis motor. What else have we got going? I've got quite a few things on the go here. This is a part that I'm trying to print with the Tevo, and it also failed printing that. It's been very disappointing. I've just been getting failure after failure out of the Tevo for various reasons, but hopefully after today I'll minimise those failures. Well, alright, I guess that's it. Enough of a moan. But I'm making progress on some fronts and having hassles on other fronts. So if you're having trouble with your 3D printers, don't feel like everything's going bad just for you. It happens to all of us. I guess that's it for me. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.